Hello everyone. So in this video we are going to look into type 4 integration of exponential functions. So let's start with the problem. So I've been given with integral e raised to the power of x log a plus e raised to the power of a log x plus e raised to the power of a log a dx. Let me just consider this to be equal to I. Now we need to use the logarithmic identity. First one which we are going to use is when we have m log a. This means it is log a to the power m. So now here if you observe in my question, I have similar approach with three of them. This one, here and here. All the three of them I'm gonna use the identity of logarithm and change it and then I'm gonna write a step. So it's gonna be e raised to the power of log of a to the power x plus e raised to the power of log of x to the power a and then plus e raised to the power of log of a to the power a and then dx. Now we are going to use another logarithmic identity. Whenever we have e to the power log of a to the power, some x is there. In that case, what would happen? These two, whenever we are having in this format, e raised to the power log. In that case, it's going to be equal to x. Because we know that logarithmic is an inverse of exponential function. That's the reason. So now here, what would happen? I would be getting e and log wherever we are having everything would vanish and we would be left out with just a power x here and x power a here and then I would be having a power a here. So the result what I'm going to get here after applying the properties of identities of logarithms, I would be getting something like this. A power a dx. Now I would be proceeding with my integration. So here it is going to be integral a power x dx. We have a integration formula for that. Whenever we have integral a power x dx, it's going to be a power x divided by log base e of a. Right? So plus integral x to the power a dx. Instead of n, I have a this time. That's the only change. Plus a to the power a is a constant, and then we have dx. So I would be having a power x divided by log base e of a plus x power a is gonna be x power a plus 1 divided by a plus 1 and then plus a power a into x plus c. That's it. I hope you understood. We are using logarithmic identities here and the normal basic integration formulas in the beginning stage what we learned. That is integral x power n and then taking out the constant using the standard result and then the integral a to the power x dx. These are the three things which are using there. Now let me go with the next one. So here we have something integral we have the fractions x by m plus m by x plus x raised to the power m plus m raised to the power x. So when we have constant raised to the power x, we know which identity to use for integration. So we would be using this particular formula for integration. So let's start with this. So see here, I would be writing it. First, let me just remove the constants. And then let me have integral x dx plus m into integral 1 by x dx plus integral x raised to the power m dx plus integral m raised to the power x dx. So here I would be having 1 by m. I would be getting x square divided by 2 plus m ln of mod x and then plus x raised to the power m means x raised to the power m plus 1 divided by m plus 1 and then plus I would be having n power x divided by log base e of m plus c. That's it. With this, it's over. Even here, you can do a little bit of arrangement and write it as x squared by 2m. And then you can finish the problem. Hope you understood. So I would write it as x squared divided by 2m plus m ln of mod x plus x raised to the power m plus 1 divided by m plus 1 plus m raised to the power x divided by log base e of m plus c. So with this, it gets over. Let me proceed with the next problem. So so here we have, let me consider this as I is equal to. Here what we are going to do, I'm going to split it into two because I have a common denominator for both the terms of my numerator. So we have 2 to the power x divided by 5 to the power x dx, and then 3 to the power x divided by 5 to the power x dx. The formula is going to be the same thing which I'm going to use. Integral a to the power x dx is equal to a to the power x divided by log base e of a. This is what I'm going to use. Okay. But you would be thinking like we have like 2 by 5. So how we are going to use it? So it's simple. I'm going to consider 2 by 5 whole to the power x. Because we know when we have a to the power m divided by b to the power m, in that case, though the base is different, the powers are common. So I would be writing it as a by b whole to the power m. So that's what I'm writing here also. So here I would be having 3 by 5 whole to the power x dx. Now I would be using the integration formula which I just wrote above. So here I would be having 2 by 5 whole to the power x divided by log base e of 2 by 5, and then plus 3 by 5 whole to the power x divided by log base e of 3 by 5, and then plus c. That's it. It gets over. It's a very simple problem. The thing I need to know the identities and the logarithmic and the integration formula. So here we are using exponential laws. Under that it comes. Now we will move on with this one. So here in this particular problem, if you observe, we have a to the power x plus b to the power x whole square divided by a power x b power x dx. Let me just consider I is equal to. Then in that case, a to the power x plus b to the power x whole square. I'm gonna use a plus b the whole square is equal to a square plus 2ab plus b square. So this, when we multiply it twice, we would be getting this one. Okay. So that is what we are using here. So now let me just expand it. So now I would be having a to the power 2x plus 2 times a to the power x, b to the power x plus b to the power 2x divided by a to the power x, b to the power x dx. Now, so now what would happen? See, this particular denominator is a common thing, common one, and this denominator is common to all the three terms in my numerator. So I'm going to split it and write it so that I would be able to do the cancellation part, and then I would be able to proceed with my integration. So I would be having a to the power 2x divided by a to the power x, b to the power x plus 2 times a to the power x, b to the power x divided by a to the power x, b to the power x plus dx, we have here also dx, plus integral b to the power 2x divided by a to the power x, b to the power x dx. Now what would happen? One of them would be getting cancelled here. If you observe, um, um, one of it would be getting cancelled. And here both of them are common, it would be getting cancelled. Here b power x would be in the denominator, would be getting cancelled. And I have in this format a by b whole to the power x dx and then plus 2 integral dx, and then plus b by a whole to the power x dx. I have used this exponential law wherever I have a power x by b power x. So now here when I integrate this one, I would be getting a by b whole to the power x divided by log base e of a by b, and then plus 2 times x plus b by a whole to the power x divided by log base e of b by a, and then plus c. So that's it. These were the exponential problems. Using exponential functions of integration, we have solved it. So I think you would have got a better idea about it. In the next video, we would be looking into type 5, which is a miscellaneous problem. Two or three problems with the miscellaneous kind, we would be solving it there. Thank you.